Let's talk about redox reactions. They're great. Redox is a word that we made up, that we chemists made up in order to emphasize that reduction doesn't ever happen without oxidation. It's two kind of sub-reactions happening together, and you never get one without the other. So in order to kind of help sort out what's happening here, we have this little saying about Leo the lion. Leo says grr, all right? So Leo the lion. Leo is the name of the lion, and this is to remind us that when an atom loses electrons, when we have loss of electrons, that means that that atom is undergoing oxidation, okay? So loss of electrons means oxidation. Grr is the noise that the lion makes, grr. So that is to remind us that when an atom gains electrons, it's undergoing reduction. All right, so you should be amazed and impressed with my skill at writing vertically. That's something I practiced. Okay, so Leo says grr means that loss of electrons, we have oxidation. Whatever atom is gaining electrons is undergoing reduction. And so sometimes it's hard to figure out which one is doing which, honestly. So it's helpful to use a number line to just say, here's the 0, here's 1, here's 2, -1, -2. You remember number lines from your past life in math, right? So let's grab a different color marker and look at this. So if we're going in the negative direction, so we start anywhere over here and move any way that direction, we're moving in the negative direction. Now, if electrons are negative and we gain more electrons, the charge on the atom should be getting more negative because it's getting more of those negative things. So we would say, going in the negative direction, that we're gaining electrons. The opposite ought to be true then. If the charge is getting more positive, that would mean that we're losing electrons, right? So that would be a loss of electrons going that direction. So how do we tell whether we're gaining electrons or losing electrons? We go back to those oxidation numbers we talked about just a little bit ago in a different video. So we look at our equation here. This is a nice simple one, simple example where we have a solid metal, magnesium. This is not magnesium dissolved in water where it has a charge. You can't look at the periodic table and say, oh, I know it's always 2+. No, this is magnesium. All by itself, completely by itself, is like a solid chunk of magnesium, a metal, okay? So if it's all by itself, it has nobody to share a charge with, it has to be 0. This oxygen is oxygen gas, like we're breathing right now, you and I, right? So it has nobody to share a charge with. It's got to be 0 also. This is an ionic compound that we know, metal and nonmetal, and we know how to assign charges to it. And any ionic compound, we know that its oxidation numbers are exactly equal to its charges. So we just put those down. So now all we need to do is decide who's changing. Since there's only 2 players here, both of them are changing. But in a redox reaction, there's always one player, one element that is being reduced, one that is oxidized. If you have 5 or 6 elements in a redox reaction, there's all of them are, you can analyze all of them. Only one will be reduced. Only one will be oxidized. The others don't change. So if you think that 3 things are being reduced, you're probably wrong, okay? So let's go figure out what's going on here. Here it's easy. They're both changing because there's only 2 of them. Magnesium is changing from 0 to +2. Which direction is he going? He's getting more positive, so therefore he's losing electrons. And loss of electron is oxidation, so we can say, oh look, magnesium is oxidized. Okay, and going from a 0 to a +2, that's oxidation. Oxygen is going from a 0 to a 2-, and so that is going in the negative direction. That's a gain of electrons, right? So gain is reduction, so we can say oxygen is reduced. Usually, when we talk about oxidizing and reducing, or who's oxidized and who's reduced. We just talk about the element. If this were a complicated formula here, we would still just call out just the element. We wouldn't say the whole formula. In this case, there only is an element. But that is, on a very simple level, a redox reaction and how to analyze who's oxidized or reduced. Now, in the next video, we'll do a little more complicated example.